So what we decided to do is to begin with an overview of machine learning and artificial intelligence. I know that many of you already have some expertise in this space. So what I wanted to do is give everybody up to speed so we all have the same level of understanding before we jump into the details about how it could be specifically applied toward the future of work. To begin, let's just talk about the simple, everybody goes to Webster. So we'll say Webster's definition of AI. And it focuses specifically on intelligent human behavior, imitating intelligent human behavior. And to date, there is no example of a general purpose artificial intelligence system. It doesn't exist yet. It's in development. Computer science is working toward that. But what we have is a subcategory that everyone is working on in machine learning. Machine learning is an aspect of artificial intelligence, just like natural language processing and other elements like that. So when we say AI, today I'll mean ML, and both together is the same meaning. So they're often used together. Before we employ machine learning or artificial intelligence in any solution, we need to first understand why it's effective and how it works. Because if we don't understand how it works, we may use it improperly or be sorry we actually employed it, because it does come with additional risk. In classical computing, we've all written software, I'm sure, in the past. Classical computing is if, then, else, and do these specific statements. It's very structured, it's deterministic, predictable, and explainable in general, unless you write some very cryptic software like I do sometimes. But it's typically very explainable. Artificial intelligence machine learning is probabilistic. What that means is it learns the statistical likelihood of a specific event, which means it may be wrong. It may be right. It's statistical probability instead of deterministic. It also is used to find structure where humans can't find structure. It's used to analyze large data sets and look for patterns that we typically wouldn't be able to see. 10-dimensional space analysis of data sources, that's just not what the human mind can do well, but machine learning can do that very well. It can also predict events that humans cannot. AlphaGo, for instance, predicted and used moves that no Go expert ever thought of. And they were shocked at what it was doing. They had never seen these moves before. It's because it's used this different method for learning. And then finally, deep neural nets and many applications of these networks are effective and very powerful, but inscrutable to humans. We cannot understand how they work today. We can't defend them. We can't analyze them. We can't interrogate them. The way they behave is extremely complex, and they're extracting information that we don't necessarily see. And I'll show you what the result of that in a few examples coming up here in a few seconds. And there are three basic types of machine learning that are employed today. Supervised, which means the algorithm is given specific...
Chris, this is Jay. I'm going to interrupt you for a second. I don't think you're sharing and advancing the slide.
Slides are not advancing.
Oh, okay. I'm not sure. Okay, let's try that again. Sorry, very sorry about that. So let me share my screen instead. How's that?
No, it just went away there.
It should come back now. Do we have it?
You have it. There you go.
All right, now we're good. Sorry about that. So what we have are three basic types of machine learning. Supervised, which means you label the data. You say, this is a cat, this is a dog, and you give it to the model to learn from this cat thing and this dog thing what they actually are. Unsupervised is employed when you look for patterns among data you don't understand yet, or you just give it a bunch of data, and it tends to cluster or do distance measurements of data clusters and tells you what's like what other things and which things are related, which ones aren't. That's unsupervised learning. And then reinforcement learning, which is AlphaGo and Microsoft Tay. You teach the algorithm based on rewards. And it seeks to increase its rewards and find new ways to discover rewards out of a problem space. Here's the problem space, find ways to solve the problem, and the more ways you solve, the more reward you get. And this is how machine learning typically works. This model is supervised machine learning, which is the most popular, most common. And you have the physical world begins on the left-hand side. You take samples of that and you feed it into training data. You collect a training data pool. You feed that into a training model so that the model learns from that data pool. You develop a learning model. This is the model that you're going to use in your development. You test it and analyze its performance. You adjust parameters, you tweak the algorithms a little bit, you look for features and specific aspects and its accuracy, and you compare how it's performing versus other models. And you come up with your optimized performance model that turns into your application, your inference application, and that goes into production. So it's an iterative cycle. It's often you look at your data, you analyze the data, you feed the model can't figure it out. So you look at the data some more. So let's analyze what's wrong with the data. Is it not grouped properly? Is it not labeled properly? You work on it some more and it sort of iterate through the process until a model comes out with the answers you expect. And it's accurate and reliable. That's the typical process for machine learning development. As you can see at that point, that's a bit different than your typical programmer sitting down and writing up code. It's an extremely different model, different development model. Now, because machine learning is different, we have to think about its vulnerabilities in different ways. One of the most common and most reported by the press recently is classifier bias. Selection, automation, and reporting and group attribution bias. Those are different aspects of bias that models can develop, but they don't develop them because they're mean models. They develop them because they got data that was biased. Source of input was biased, which leads me to my most important point about machine learning. The data is what's important, not so much the model. The data you feed it is what determines how the model behaves. So if the data source is biased, your model will be biased. If the data source is representing the entire population of your target, your model will represent your population for your target environment. The data is critical. And what goes into curating data is a tedious, onerous process of looking through terabytes of information, sampling it, looking at the trends of the information, looking at the way the data is distributed across a normal curve, looking for unusual samples inside the data is extremely tedious, but it is the most important piece of work to do in developing a good machine learning algorithm. Otherwise, you end up with bias. There's also significant attacks on machine learning that we need to be aware of. How machine learning can be vulnerable to outsiders influencing it and changing its behavior because they manipulated the information somehow. And that's what I'll cover next. So now we have the machine learning training models. We talked about historical data, feature engineering. What we do in this ML training, a little more detail behind this, is we take the training data set. Here's training. We split the data set in 3 pieces. You take a group out for training, a third out for validation, and a third out for holdout testing. The third you suck out of the data, just randomly sample out of the data, is used for training, and that's what you submit the model to learn the distribution and the features of the data and how it can detect specific events in that data. Then you validate that with a different data set, which should be equally sized, equally complex, to see how the model performs against information it's never seen before. The validation set is a totally new set of data from the large historical data pool. Then, once you get the results you expect, you finally do the test. You hold out with test data, and you submit a whole new set of data into the model that it's never seen before and see how it performs. You look for test results. You may compare different algorithms to see if is a linear regression algorithm better than the random forest or whatever models you decide to pick. And then you say, I've got my model. I'm done. I've got the results correct. With all this, you don't really write code. You're taking a library model and saying, how do you respond to this data set? Is it what I expect? Do you detect properly or no? If you don't, try a different model. Adjust the parameters a little bit, change the feature set a little bit. It's very much art. And that's where it gets to be dangerous when you try to apply it. And let's take this one scenario. We're going to apply it to detect cats and dogs. Let's just say our model is going to be a great detector of a cat versus a dog. So you feed it all lots of historical data about cats and dogs. And you say, these are cats and these are dogs. So look at all these pictures. These are cat pictures. Look at all these pictures. These are dog pictures, and label them accordingly. Then you say, training data set. let's train it with this 1/3 of that historical data and feed it these pictures of the dogs and cats. Then we're going to validate it with a different set of data to say, does it detect a cat properly? Does it detect a dog properly? How often does it detect them properly? Is it significant enough or accurate enough for our purposes? If it is, we move on to holdups, a different data set, and feed it to the model and say, now how do you just parameters and looking at how I'm doing. Let's do some performance analysis, see how accurate we're getting with a whole new set of data. And we're trying to see now, can it detect properly from this third set of the sample, what's a cat and what's a dog? Now here's where we come into bias. What happens if we've never shown this model this picture? Now that's a cat, but it is a weird cat. It has no hair and it is shaped funny. It's got this, looks like a rat-like tail. What is this thing? Is this a cat or I can't tell? So the model says, based on what I know from all the samples I've gotten, I guess that might be a dog or it might be a cat. And I have about the same amount of uncertainty about this thing. So I'm gonna, because I got 10% more, I'm gonna call it a dog. So what comes out, unless you give supporting information that says my confidence level, the only thing the user sees is dog. Now, is that right? The model thinks it's right. It's the best guess it could make based on what it knew, but it's not right. But if a user doesn't know how the model works and they see dog, they're going to say, okay, that's got to be a dog. There's no question, it has to be a dog. I'll operate based on the fact that's a dog. And that's where bias error comes in all the time. It comes in because the sample data wasn't sufficient and it didn't give you the information you needed to train the model properly. There's also, I'll give a couple samples of attacks, and I'll finish up with the most interesting attack that I think is going to be coming up in discussions about deep fakes and videos and such. But this is a poisoning attack. Is you as an attacker feed bad data into the training cycle. So you have somehow given bad data to the trainer of the model, and you inject some data that's meant to change the classifiers in favor of your goal of the attacker. So that's one example of an attack where you can poison the training data. That's during training phase. There's evasion attacks that learn model detects something, most often used in malware detection or spam detection, where you send information and you discover what it looks for based on what it fails on. And you say, okay, now I'm gonna do one of two things. I'm gonna make it learn wrong stuff. So I'm gonna try to put information in it that's just slightly off its course, but it still accepts as true. So over time, if it's learning from that, like a Bayesian algorithm, it'll get worse and worse and worse and worse and worse and worse and worse. And then you can easily get in and inject your attack. Or you can learn what it's looking for and just change your information that you're sending, you want to submit in just a little bit. That's why some of those spam filters still let some emails pass through, because they've learned what most spam blockers look for, and they tweak their messages just a little bit, and it slides right past and works. And the last sample I'll give you today, this is not all the attacks, but the impersonation attack is very interesting because you're learning from the model and you're pretending like you're somebody else. You're confusing it by submitting that I'm not really B, I'm C. So you imitate samples from victims, often application of images, recognition, malware, et cetera. You inject malicious data that is meant to classify the original samples with different labels from their impersonated ones. You spoof for identity control. Examples are facial recognition system impersonation, unrecognizable speech recognition. I've seen samples of a noise presented to an Alexa or a Google Home, just some weird sound, and it detects as it's confident it said someone said a word, and it uses it as an information. So that these are called impersonation attacks. You're impersonating the right data. And deep neural network attacks on self-driving cars and deep fake videos are all examples of impersonation attacks. Here's an example of University of Washington. They developed a model which was to be used by self-driving cars to detect signs. Now, what do you see when you see that sign? I bet you see a stop sign, right? You see a stop sign with some white and black boxes on it, but it's still, to any human on the planet, that is obviously a stop sign. Here's what the model thought it was. Here's a more subtle example. It's really using shading. Stop sign or not a stop sign? I think it's a stop sign, but the model said, nope, it's 45 miles an hour. Because of the way it was trained, it wasn't robust enough to be able to look around these minor adjustments. Now you see here, this is a problem with deep neural networks. You have a stop sign, but you don't know what the classifier is using to detect it as a stop sign. It's using features that really aren't deterministic features. It may be using some shading features that really aren't robust. But you don't know that because it's a deep neural net. It's got this complex analysis system that is hard for you to understand as a tester. And it may come up with some strange answers because it's using different features than a human would. So that's the background of artificial intelligence and machine learning. Now we can talk about how it applies to jobs. Sherri, would you like to pick up from here?
Thank you, Chris. And that was a great background on AI and ML and some of the implications as far as the technology and algorithms. So we want to now apply it to work and ask a few questions. What is the future of work? What jobs will there be? How will we work? Where will we work? What are the social and political implications? So what jobs will there be? Well, when we talk about artificial intelligence, it's common lore and some common knowledge for people who are in jobs that have been changing, that some jobs will be lost. We think about call centers where we may no longer have humans who are answering those calls, but robots. Drivers. We know that we have many kinds of drivers. We have people who are driving their own vehicles. We have bus drivers. We have all kinds of delivery drivers. In fact, I've seen a statistic that says that the most popular job in 29 states is as a driver. Doctors, you may not think about, well, are doctors going to lose their jobs? Well, portions of their jobs, of surgeons, for instance, already have been changed because they are directing or managing in the OR, in the operating room, but what they're directing or managing are not other humans, but actually robots. And even lawyers. We see now that with AI, that there are instances where you don't have an actual human lawyer, but you can, through AI, have certain types of cases that you can use an algorithm for. Also, proofreading, which at large law firms used to be a very big job. You don't need human proofreaders anymore. But on the other side of this equation, there will be all kinds of jobs that are gained. So you will have all kinds of new technicians. You will have new data scientists. You will have new positions in telehealth and in healthcare in general. And I think it's important to note that when we talk about these robots, and I already gave one example in the operating room, you will have new positions with people who are managing and monitoring AI and robots and machine learning and algorithms and looking for bias and some of these things that Chris has already spoken of so eloquently. In addition, you will have new jobs where you will have people who are working really side by side with AI and with robots. Next slide, please. So I think it's important also when we talk about the future of work, you have to have a way to get a job, right? So how will be hired and hopefully not, but potentially fired, right? How will this happen? We're used to a situation perhaps where, there's somebody who's in human resources or a CEO, and they look at all the resumes and they make decisions about who they're going to interview. Is that how things will continue? Is that how things are working now? Do we, for instance, have a situation now where we actually have AI being used to make determinations about who's going to get an interview? And could there be bias in that, right? Then once we're hired, our work is evaluated and our performance. Right now, we may be assuming that a human is evaluating our work and our performance. There are metrics, we hope, but could this be a situation now or in the future where actually there are algorithms that are monitoring our work and our performance? And will that then determine whether we have pay raises, whether we have new positions, whether we're hired, or unfortunately, whether we're fired? Next slide, please. So how will we work? This is a really important question. How will we work? Broadband, as we have seen with all of the changes in society, And with the COVID-19 pandemic, which has just accelerated a lot of these changes. It's accelerated, for instance, telemedicine and telephonic medicine. It has accelerated changes in work and where we work. And I think it's really important to see broadband as a utility, given that we see so much education from home and so much work from home. In 1936, the US Congress passed the Rural Electrification Act. Yes, 1936, United States Congress, Rural Electrification Act. I would contend that now is the time actually for Congress to pass a Universal Broadband Act. Because again, with all that we see, all the changes, and I think that we're not going back, right? That is very important. Also, workforce and education, right? And this goes from the time that we enter school, maybe in kindergarten, through high school, and then after high school. Are we going to be in training? Are we going to go to college? Are we going to continue beyond that? But we need to have a pipeline for these new jobs that we're seeing created with AI, for new ways of working along with AI. And we also need continuing education, because our jobs and how we do them and the way that we are working along with AI will continue to change. We also are going to have to face retraining. There are people, as we said, whose jobs may not exist anymore. Okay, so they will need to be retrained for a totally new type of job. And then there may be people whose jobs exist, but in a different fashion. And so they will need new training. I think what's important is that we have to expect that we will continue to see changes, and we're going to have to adapt and change. We are going to need new skills. We are going to need new cognitive skills and analytical skills. And I think that critical thinking is going to be more and more important, and creativity, I think, will be at a premium. I also think that we will need to continue to explore, in fact, what are those new skills as we move along. That will not be static. Next slide. So where will we work? I certainly alluded to this when I was speaking of the need for broadband. Right now, as we have seen with COVID-19, as I mentioned, we've seen a lot of changes in where people work. Yes, before that, we were already seeing changes. We were seeing various companies and governmental entities experiment with what we called telecommuting or telework. But what we have seen now is a wholesale move of many people to an environment where they're working entirely from home or mostly from home, some type of hybrid. Some people either by choice or frankly by the nature of their jobs don't have a choice. They are working still in a totally in-person, face-to-face environment. But I think that some of these changes will be permanent, whether people continue to work entirely from home or in this hybrid mode, where maybe they go into an office once a week. And so this has a lot of implications with AI and the platforms that we use, right, to work from home or for wherever we're working, and what that means as far as, and I know Chris will get into this more, what this means as far as potentially AI and privacy, right? If you're working from home and you're on a device that is owned by your employer and you are using software, your employer wants to make sure that's secure, right? But is AI monitoring your emails, for instance? Also, spatial planning. We will see AI, I believe, used in looking at how we plan our space in our offices, and with our new workforce and workflow, with whether this is hybrid or in-person or remote. And so I think that we will see AI being used both for the spatial planning and design of offices and also for workflow. And then when we talk about where will we work, geography is, for many people, no longer a limiting factor. If they are working completely online, just as we see today when Austin Forum on Technology and Society when we had all of our events in person, which was wonderful to see people and, you know, have happy hour afterwards, but you had to be in Austin. So if we look at the glass as being half full, one advantage of now being in this remote Austin Forum is that people from all over the country and all over the world, right, can be participating. And we see the same with many people in their work. They don't have to be in a fixed location anymore. And so will AI play a part in that, in our work and the geography of work? Next slide, please.
Thank you, Sherri. That's an excellent backdrop to some of the technical issues for machine learning and artificial intelligence. Can you hear me okay?
Yes, please.
Okay. So that's a good backdrop for the technical aspects. So what does it mean? What does ML/AI mean for the future of work itself? And Sherri already mentioned that machine learning is often used to scan or review resumes for companies. Now, that scanning depends upon natural language processing, which is the understanding what's being said, and then looking for patterns and looking for distribution of data from that indicates some aspects that you are looking for in an individual. Does that include unintended bias to screen out qualified individuals? How do you know it doesn't? Can you prove it doesn't? Is there any way to really detect if it is or is not happening? And we'll talk about in a minute, the best way to detect that is to look for it's called a confusion matrix, which is you look for the data, you look at what's positive and what's a false positive, what's a false negative for all aspects of the yes or no analysis. And you say, based on this matrix, we're getting what we expect from the population. But you need to do that work before you employ these tools. Worse still, if you buy a product from a third party, most often you won't be able to interrogate how they analyze those resumes. You'll be told this is the result, and the algorithm is intellectual property, so we can't tell you how it works. That's extremely difficult for a purchaser of that product because there needs to be some way to provide transparency that the system is working as you need it to, and that you, even though you're using a third-party product, you can defend any accusation that you're not biased in your hiring. So that's one example where employment, it can be a great tool to scan through large numbers of data sets, but it also can scale bias in a way you don't intend to. Additionally, one of the issues that I'm hearing quite a lot from people I work with and the customers I talk to is that how do you measure performance when people are working from home? Do you know they're delivering what you expect them to? And of course, the answer should be, well, if they're producing like they expect, that's what you want, right? But in many cases, many of these workers are knowledge workers. They're doing more advanced work that's not so much measurable by work product. So how do you know they're really performing as they should be? Well, some examples included analyzing social graphs and interactions. So you look at all the text messages and all the messages, the Slack messages they've exchanged back and forth, and who they connect with and how often they connect with them, and measure the distance of their social graph and the depth of the interactions, and that person is doing better than other people who don't do that. Is that really true? Do we really know that's true? Is that really a good performance metric? Some are questioning that assessment. Also, you can analyze recorded video in meetings and contributions and interactions like we're doing right now. There'll be a recorded session after this, and you can watch how much Sherri talks, how much I talk, how much Jay talks, and look at how they interact and how people respond to that talking. That could be a way to measure how influential a person is, how much they're contributing. But what if it's a deep fake video? What if it's not really me, it's somebody else doing that, and I'm getting credit for that work? Is that really accurate? And then finally, there's sentiment analysis. Sherri mentioned before, we may be being answered by robots in a call center because it's artificial intelligence. Well, right now, many call centers receive the first, you may say, you've heard prompts at call centers saying, what is it you want help on? What would you like us to help you with? What is your issue? And you speak something out, they record it. That's recorded for sampling the words, but also to look for your attitude. If you sound angry, they'll redirect you to call center agents who are good at handling angry people. They're carefully looking for how to best manage the inflow of requests with the people who are most skilled to handle that type of person. And the same is true of emails. You can get sentiment analysis from emails. Sentiment analysis is an important topic for insider threat investigations too. When you have lots of people working from home, they're not being monitored. The tools you used to have to control the flow of information in your enterprise are not in place. And insider threat is becoming more of a severe problem. So you look for the sentiment of that person's communications, maybe even what they post on Twitter or what they post on Facebook, and see if they're getting disgruntled or angry or say bad things about the company they're working for. Those could be used as indicators of a possible insider threat risk. Now, are all these the right things to be doing because they can be done? That's a question that we all need to discuss and really consider before we jump in. Are we employing the right tools with the right data in the ethical way to support our workforce? So I work in Cisco systems, and I'm responsible for our artificial intelligence security and ethics requirements for our products. That's one of my jobs. So these are the kind of questions that we ask our engineers. The first thing we should do before we employ machine learning or artificial intelligence is, do we really need it? Because it brings along extra risk. Like I mentioned before, it's probabilistic, it's not deterministic. It may make errors. Do you really need to use it? Can you get away with simple heuristics or some basic heuristics that do statistical analysis, like 35% do that, 25% do that. Let's use that data as opposed to trying to apply a machine learning model on top of it. If that's possible, go that way. Use that approach instead. If it's not, you choose AI and ML as a way to go, then engage the expertise and domain experts. A critical aspect of our fairness and human rights rules around artificial intelligence is engaging with people who are expert in the domain you're dealing with. If you're dealing with facial recognition, then you deal with experts in facial makeup across demographics, across different ethnicities, so that you can take their guidance in how you build your model to make sure your data set's accurate, that's recognizing properly. Engage domain experts as part of this model to make sure that you can do that. If you're buying an algorithm from someone, make sure they did this as part of their process, that they engaged domain experts. And as I mentioned before, machine learning is all about the data. Make sure it's accurate, clean, and represents your population. Judiciously develop the model and make sure your vendors do the same thing. Make them give you the information about their training set and the information about their test set and the information about their validation set, so that you can learn if they really did what they should be doing. Take those little bits I share with you today and use them to validate your vendors who are doing the right thing. And then validate its performance. If the model outputs this information from this source, is it plausible? Is it feasible? Does it make sense? If not, fix it or go back to your vendor and say, this doesn't make any sense. This is the statistics are wrong. They don't represent the population at all. And then finally, and equally importantly, of all these 5 before is the 6th one, which is monitored during production. When this model is running, make sure you check it to make sure it hasn't drifted. The data has been given hasn't drifted. Microsoft Tay did this. Microsoft had a Tay chatbot, which was a machine learning based chatbot that interacted with individuals, and it learned, supposed to behave like a 19-year-old, I believe it was, to talk to people that chatted with it. And it would respond in a similar way as a teenager would respond. But it learned from interactions, and it was attacked by people, making it into a racist maniac. It turned into this evil thing, saying swearing and all this. And it took a while for Microsoft to catch it, but they were monitoring it. And they saw this was going far adrift, shut it down, take it offline. Don't just assume it's working in production. It can drift, so be careful about how it behaves in production too. Those are the 6 main points I wanted to bring up with you today about how to properly employ machine learning.
Thank you so much, Chris. Those are very, very critical ethical implications that you have illuminated. And with good systems, we are focusing, in fact, on the ethics of AI and AI for good. But when we talk about AI and work and the future of work, there are many social and political implications. I'm going to start and put one up front that many times is not up front, and that is childcare, childcare, childcare. In some ways, I feel like we are back to the future with this. It has been cussed and discussed for many years, but not a lot of movement. I know in my own career, this has been an issue for and was for many, many years with my husband and myself, with small children and working. And as many of you know, all small children get sick at about 3 a.m., right? That's just the way it goes. But beyond that, with our new work environments that we've talked about and with AI, what does this mean as far as the work environment and childcare? Can we use AI to have childcare more available? I hope so. I hope we can use it for good. And I hope one of them can be, frankly, to have high quality, accessible, affordable childcare. Another one is, of course, wages. And what we are seeing is economists beginning to talk about and rethinking and reimagining labor and wages. If we are using more AI and more robots, as we have discussed, what will this mean for wages? Will people be working fewer hours? Particularly in developed countries where wages have been higher, will this mean lower wages, or because of fewer hours, will this mean people need more jobs, taking on second jobs? These are very important considerations. What we mean for wages. And of course, universal basic income has become a topic. People have different views on it, but it has become a topic. And I think it will more and more because of this issue of wages and the work week and work hours. So I think that these are very important considerations when we talk about income and the future of work with AI and ML and employment. And what does employment mean? And what does our daily life continue to look like in the future? As we see more AI employed in the workforce, again, will we be working future hours? Will we be working alongside robots? What does that mean for our interpersonal interactions or lack of interpersonal interactions? What does this mean for us as humans and our lives and our quality of life? If we do have more free time, what will people do with that free time, right? What will their daily lives look like, their weeks look like, and how will they use that free time? And I think that these are important considerations when we think of AI and the future of work. What will this mean, not just as far as our wages or our actual jobs, but our satisfaction in life, whether it's in our work life or our home life or our free time. And there are also many, many public policy implications when we talk about AI and the future of work. And certainly Chris has mentioned some of them. When we think about ethics, bias, the algorithms are only as good as the data that we input. And if we have bias in that data, does that lead to systemic racism? Does that lead to discrimination? What does that mean as far as any policies or regulations that we may have? What does this mean for policies and regulations regarding both privacy, right, and security? These are important topics. And it also lends us to start thinking about standards. You know, if you look at Europe, we have seen more of these standards for AI. Do we need standards? Do we need public policy around standards in the United States? And if so, should this be at the federal level, at the state level, at the local level? all of the above, right? How do we handle this? And how do we handle standards and ethics and lack of attention to some of these important topics, such as bias? Because as Chris said, we need to think about when we use AI. I do not think that AI should be just a shiny new toy, right? And from a public policy perspective, we need to think of it as how can we use this very powerful technology for good, and how can it assist us in our daily lives? And I think it's a valid question to ask, do we need standards and policies and potentially even some regulations around some of this? So with that, I want to thank you for being with us today and being part of this conversation, which I know will continue. And please join us at Good Systems at the University of Texas at Austin. And if you want more information, we can provide that. So Jay, we will turn this back over to you.
Great. Thank you very much, Sherri and Chris. Thank you also to folks who've asked questions in the Q&A feature of Zoom. We should be able to get to a handful of those before the 7:30 bottom of the hour meeting close. But then remember, we have another half hour of extended Q&A. That's been a real popular part of the Q&A, the extended Q&A, and that's where we'll promote people to live to ask their questions. So we'll try to get through them pretty quickly here before the 7:30 formal end of the meeting. So I'm going to ask the speakers to be precise on this. I do want to set a little context for all of our future question askers and just make sure that we've summed up some things here pretty well. Sherri and Chris, again, thank you for the presentation. Chris, really appreciated your explanations for how machine learning and AI are different from explicit programming methods. Appreciated the explanation that I always have to share with my friends about the need for understanding that the answers are probabilistic, and also, especially in deep learning techniques, not even reverse engineerable, that you have to develop trust a different way in these methods, not through understanding the answers they make, but through the testing and the monitoring. So thank you for bringing that up and including my favorite example of Microsoft Tay and how that went to hell in a handbasket in 24 hours. Sherri, really loved your explanation about the kinds of impacts this is going to have on the workforce, but also the societal impacts that this is going to have in changing the nature of society overall, and why some of these other issues we talk about in election years and things are relevant to AI doing more jobs. So I'm going to start with the MC prerogative and ask a question of Chris, and then start asking from the list here. Chris, you mentioned this bit. You mentioned that this is probabilistic and that we can't even always reverse engineer the answer. One of the concerns I have is that we're not always training our students to be comfortable with uncertainty and probability. People want to believe it's a cat or not a cat. It's one of the challenges we always had in physics of getting students to understand quantum physics and the inherent uncertainties and probabilities there. How do you recommend we train this next generation of data scientists to be comfortable with probability and statistics? And then, Sherri, how do we train the public to be comfortable with the fact that the answer may not be a sure thing? We may change our answer on pandemic treatments or precautions or whatnot based on data. Can you two speak to that a bit? Getting people comfortable with uncertainty and probability?
Sherri, you want to start, or you want me to start?
Chris, go ahead and start, and then I'll follow up with some specifics I have on curriculum and education.
Good, good. Yes, one of the research projects that we worked with Sherri was on very much this point, which was the disconnect between the industry and society about what they expect from AI or what AI can do for them. And I think to train students about being comfortable with uncertainty, I believe we would do that by starting with explaining how the system works. That uncertainty is part of the way the system works. It's probabilistic. It's assessing what it thinks is the best answer based on what it knows. And if it doesn't know all it needs to know, the answer will be wrong. So that's going to be an important part to And I think that works mostly for me too when I'm teaching about artificial intelligence, is that when people understand the difference between deterministic programming and the way machine learning works, and they understand the difference between a yes answer and a no answer versus a maybe answer.
That's right. And as we know, not everything in life can have a yes answer or a no answer. And I think that it's very important, and we found this from the research that we did working with Chris at Cisco, to have very specific training, starting from technical training in undergraduates all the way through people who are getting their PhDs. We were exploring in our research the ethical, policy, and regulatory implications of AI and ML. And we did structured interviews both with people who were creating these algorithms in academia and industry, and with policymakers, right, who are dealing with AI, whether they're elected officials or appointed at all level, or even with interest groups. And what we found when we asked folks is universally, they said, we didn't have the training we needed in this to understand the implications, to understand uncertainty, to understand bias, to understand ethics and implications. And so I really think that what we need, Jay, for our students is a curriculum that is interdisciplinary and multidisciplinary, both as far as the students in the room and the faculty.
Great, thank you. And Sherri, one of our questions from Brad Engler is, how does UT define a UT Grand Challenge?
Okay, so thank you for the question. President Fenves, who left UT a few months ago, started an initiative when he became president of these grand challenges. And there was a call that went out to faculty to put together in teams, interdisciplinary teams, papers. And from that, these grand challenges were formed. There's 3 of them, and this is the 3rd one and last one, good systems. And they are multidisciplinary, interdisciplinary. Think of them as think and do research tanks across the campus.
And you said the good systems is one of these. Is good systems all about AI? Can you describe good systems a bit?
Yes, yes. So there were 3 of them. Good systems is the 3rd in the series, and it is completely about AI. It's completely about how, as I said, do we use AI for good? How do we train people? How do we do research? And it is also about working with folks in the community. We're not just sitting in the ivory tower. For instance, as part of Good Systems, last February, right before everything shut down, we had a workshop with the city of Austin. And we had about 30 faculty members from across UT and about 30 people who are staff all over the city of Austin, thinking about AI and what projects there could be. And from that, about 7 projects of about 20 that we have with Good Systems were developed. One of them is a project that I am honored to lead with a team of faculty at UT and the city of Austin, where we are looking at how can we use AI to both determine who may enter what I call the homelessness continuum, because I don't believe that homelessness is one state. People experience homelessness in different ways, and how can we better provide services for them? So that's just an example.
Great, thank you. All right, I got a great question here from Bill Boas that relates to something you brought up. If the algorithms are used for analyzing people's work, should it not be a legal requirement that the code generated by the algorithms be open source and locatable on GitHub, for example?
That's a great question. And I think that gets to the challenge that we face with machine learning. The algorithms typically are open source. What's not is the data to train the algorithms. So that's where we hit the crux. And sometimes the data is untenable. It may be petabytes of data. You can't put that on GitHub. You can't share that with scientists to use that information. So machine learning is a strange bird in that the algorithms are typically open source, but the data to train them is not.
And in fact, the data, when we talk about future of work and hiring, can be all important, right? So if you have a situation where let's say that you're hiring for a new police cadet class. And the data that you feed in is that police officers are, I don't know, about 6 feet tall, and they are male and they are Anglo. Then when you are hiring and looking through resumes, or the AI is for new cadets for your police cadet class, it's only as good as the data that's put in. Anyone who does not meet the male, 6 feet tall, and Anglo is not going to make it into the cadet class.
If that is selected by AI algorithms trained on.
Yes, that's what I'm saying. If that is selected by AI algorithms that are only trained on that specific set of historical data. Exactly.
Well, even not if the algorithms are trained on data that includes that information.
Right. Yes, that too.
They decide that's an important feature because
Right.
that's a common aspect of all those that are hired. So it's going to use that, but it doesn't even have to be told, use this specific attribute. It may just pick it by itself.
Yes, and thank you for that clarification. Exactly.
So related question from Jeff Kirk. The discussion around making sure your data is clean really didn't discuss if your company actually owned their data. I see increasing use of AI ML to bridge databases to erase our privacy. What are your thoughts on keeping our data private from very sophisticated AI routines?
Very good question. That's a very hard problem. It's a very hard problem because there's so much of us data about us out there in the wild to be used any way you want to. It's very hard to put the horse back in the barn again. To protect the algorithms themselves. I mean, there are ways you can prevent someone from attacking the machine learning model and doing what's called an inversion attack, which then tries to find out a membership that this person belongs in this group or not. You can do inversion attacks on models, but that's for only that model. That's not a correlation attack across all data sets across the globe about that person. So it's a hard problem. I don't know how we deal with that, honestly.
It's what we call a wicked problem in public policy, right? And it's one that we're hearing a lot of discussion about in Congress and the federal level. But I would say each one of us right now, think about in your daily life, all the devices that you are using and all of your data and where it is.
I'm going to ask another related question to the last few. This was also from Brad Engler, but it ties into this well. If a company considers their ML is proprietary, how does one verify the data and model is unbiased?
Good question. And there are ways we can do that. There are good, like the confusion matrix. If you want to share that with your vendor and say, show me your confusion matrix, they'll go, wow, this guy's smart. And then they'll give you a chart that says, yes, no, false positive, false negatives, percentage of population and percentage of accuracy. And that'll tell you what the model thinks is right and then what the real population thinks is right. And you can compare the two to make sure that they're accurate. That's one way to detect bias, at least.
All right. I've got a great question here, changing directions a little bit, from Karthik Srinivasan. He says, a lot of jobs are less susceptible to displacement due to various technologies require strong soft or human interaction skills. Are you aware of any successful AI ML systems that have been developed to identify displaced workers with strong soft skills and match them with jobs that are likely to endure?
That is an excellent question. And I do not know of one off the top of my head, but I assure you I'll be looking, because it gets back, I think, to some of the attributes that I was talking about, that I think creativity is going to be very important in the workforce of the future. And creativity takes many forms, and we need to identify that and take advantage of that in a positive way. So those analytical skills, those soft skills, those creative skills, those skills that may be necessary in, frankly, monitoring AI and interacting with AI are very important. But Chris, I don't know of anything off the top of my head. Do you?
Well, the soft skills is an interesting concept. And if you look at creativity and you think that's equal to a soft skill, AI is developing music. They're doing paintings and drawings. They're actually creating copyrightable materials, which means they're sufficiently novel.
And playing Go better than any of us.
Playing Go than any human on the planet. Yeah. So, see, machine learning is at the level of a smart dog today. You teach it one specific skill and it does it really, really well, but it's not good at bridging or abstract thinking. So that soft skill I think is going to work well, where you're having to analyze data from multiple different domains and specialties and bring it together into something meaningful. That may be something that would be worthwhile investigating.
And
I don't know anything about that.
that's where I think the analytical creativity and analytical thinking comes in, and also the need for, in our education, to have this kind of interdisciplinary education and interdisciplinary courses that in AI.
Yeah.
Yeah, and Chris, I want to actually step in there, and you brought up some good points. People think of, there are AIs that can create music, and people wonder, well, does that mean that AI is creative, or AIs that can draw pictures? But a key differentiator, is music follows rules. And Sherri brought up Go followed rules, right? So we can train AIs to interpolate things among massive amounts of data, and we can train them with a rules-based thing and applying a little bit of randomness to create things that are, but it's still kind of an interpolation. It's still aligned with the data it's been trained on and or the rules, and it's constrained by that. So randomly creating some new kind of music and such is much harder. And we actually see this, the difference between the AIs that create photographs of objects or songs, where they're pretty good. Have you read any of the AI generated screenplays or even just jokes?
Yes.
They're
Yes,
terrible.
I've seen the jokes, but I do think this is an excellent point, Jay, because what I will call the out of the box creativity, whether it's in art or music, or being able to put together and make inferences in a way that the AI in the dog stage right now cannot do.
Yeah, I mean, the AI optimist in me is, our skill set is something that we can develop through our lives and things like that, but our brains are relatively finite, whereas computing is getting more and more powerful. So I fully expect the number of things AIs can do as well as humans, or at least faster or cheaper or something, to be an increasing subset. But this question Karthik raises about, he calls them the soft skills, but there's a book called The Techie and the Fuzzy, and it really refers to them as the human skills. Because remembering that everything we do is to provide shelter for humans, it's to provide products for humans, it's to provide entertainment for humans. And the higher level human intelligence means that even people with soft skills will be needed to make sure Alexa is interacting with humans, right? To make sure that AI derived content is enjoyable by humans. And so those soft skills, those anthropomorphic skills, whatever the word would be, they really remain important in training the AI to do things that humans want them to do.
It does. AI, as you mentioned, is great in finding that needle in a haystack, or, what could these particular symptoms mean for a disease that is a very rare disease, right? But when we talk about this human interaction and human-centered design, you need human interaction.
I'm going to ask one more question, then Jessica and I will close the meeting formally with a few slides, and then we'll come back to you for extended Q&A. So the last question of the Q&A period before the formal close is from Brian Daniel, and it's for Chris. Chris, what steps are you taking at Cisco to counter deepfakes? What are your concerns about how deepfakes can be used, and what are you excited about with the potential of deepfakes? There's a nice short question for you, Chris.
I'll answer that in 2 seconds or less. Cisco is not intimately involved with deepfakes. Most of Cisco's work with facial recognition has to do with our desktop collaboration units, where we detect a face and we can place a name on that person as they're talking to someone in that collaboration session. We're also doing work with natural language processing for speech recognition and doing transcription services in live. So there's not much consequence if someone puts on a face that's not theirs and transmits a deepfake video. It's just going to be represented as somebody else. It's not a lot of consequence. But the consequence comes into copyright materials, into intellectual property for ownership for individual. My persona is being taken by someone else, and there's some copyright problems there. That's where it gets to be a problem, and also the reputational issues. But Cisco's not doing a lot there in this space, but Microsoft is doing some interesting work in detecting deepfakes. They're using machine learning to detect a possible deepfake in a video. So it's like a generative adversarial network against another network, trying to find what looks bad, what doesn't look bad. So that's the basic approach they're taking. So that's promising to be able to find it. It's going to be important to find it because reputational issues and trustworthiness of video broadcast has typically been accepted as truth, right? People say, well,
Right. Yeah.
That's got to be true because I saw you do it. It was on video. And your lips moved and everything, but that's not so much truth anymore. That's going to be a serious problem. Evidentiary issues in court, holy cow, it's going to be a problem. I don't see anything good coming of it at all. I see it's going to be a disaster for.
It is a recipe for chaos.
Yeah.
Yeah, I do like your comment though about using AI to detect deepfakes created by AI. It might be the case that just as we might use computers to crack encryption schemes created by computers, which is very, very hard, then you may have to use the same kind of techniques, which will be much harder than creating the deepfake.
Yes.
In theory, at least possible with enough deepfakes and non-deepfakes to train an algorithm to detect.
But it'll be an arms race. It'll
be an arms race, exactly. Yeah. On that cheery note, we're going to switch over to our final slides for the formal part of the evening and then come back to you. We have several more questions from Roy, Daryl, Bill, Kate, Amy, Sam, and others.
Well, and I see Satish, Daryl, the names that you were just saying, because when we come back, we're going to invite you to come on as a panelist. We're actually, even if we haven't gotten to your question in the Q&A, we're going to move the Q&A to chat. And we're going to bring people on to get to ask, get on camera if you're so inclined, and get to chat with Chris and Sherri. So stay tuned. Don't go anywhere except if it's to your bar that's in your house.
We have a slide for that too. So
we're getting there.
So we want to remind everybody, thank you for attending tonight. We hope you will stay on. But if you're leaving, please note we have another great topic coming up on November 10th. That's on quantum computing. On November 17th, 2 events back to back because we were trying to avoid the election. We figure many of y'all are going to be busy on November 3rd. Also, the next week is the week of Thanksgiving. So we squeezed our 2 November events together, and we have Online Worlds and the Future of Gaming. That's the future of the gaming technologies and applications on November 17th. And we'll be playing online games, bringing you into that space, into the gaming world of your choice after that event. On December 1st, Jessica Sager, my managing director partner for the Austin Forum, is going to lead an event on tech for social good in the spirit of the holidays. And then on January 5th, my buddy Jay Williams and I, Jay Boisseau, will do our annual tech trends for 2021 and beyond. February is going to be another double event month. You could argue these are a little bit related, even tech and relationships and tech and food. So we plan to cover both of those topics in February. So we hope you'll join us for our upcoming events.
And again, please join our community. You're a part of our community now. Join us on Slack. It's really simple. Just go to the website, click the Slack button, click join the Slack channel, enter your emails, check your email for confirmation, enter your name, click create account. Voila, you're in.
Again, we really want to thank our sponsors. Jessica thanked them up front, and I want to thank them on the backside as well. We have some of the leading companies in technology, including artificial intelligence, tonight's topic, that are sponsors of the Austin Forum. We also have a number of leading Austin companies as well as tech companies, companies that care deeply about the Austin community, have been a part of bringing this series to you for years and years, believe in the importance of it. So thank you again to AMD, ARM, Ashley and Associates, Austin Energy, Austin Technology Council, Brad Englert Advisory, Cognitive Scale, Dell Technologies, Galvanize, Quantum Materials Corp, SAIC, Sutter Roche, South by Southwest, Slalom, and Valkyrie.
And as always, one thing that COVID has really illustrated is that the digital divide exists and we can do something about it. So please help us, help others get connected during COVID. Donate your devices to Austin Pathways. I've seen 2 of our friends from Austin I have the S's and the T's. Austin Pathways here. I saw Catherine Crego here. I saw Tracy on. Our residents, Austinites, need these devices to learn and work and be well remotely in this virtual world we're living in. Austin Pathways, they'll work with you to pick them up safely refurbish them, and deliver them to residents. So all you need to do is send the email, or you can call the phone number on the screen. We'll also be sending out the links to these slides. We always have our slides up after the event as well, or we're happy to connect you with them too. So please, 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 I know everybody has an unused device laying around. There are other people in Austin who could really use it.
And I know a lot of you are going to be upgrading your Google to a Pixel 5 or your iPhone to an iPhone 12, which just came out. So if you didn't have an extra device last week, you're probably going to have one in the next few weeks. So please take this information down and donate it. It can really make a huge difference to a family with multiple kids who need to connect for education reasons in particular. So again, reminder to share everything that we put out there, please. That helps us a lot. It helps people who wouldn't otherwise hear about us. So tweet, Facebook, Slack, LinkedIn. We'll start using LinkedIn more in the coming weeks. If you see the notices on Eventbrite, please share that as well. We really appreciate you sharing.
And we want to hear that for the people who are left right before, we're going to invite you for more questions. But our question for you tonight is, what was the most useful thing you learned or heard tonight? So put it in the chat feature, start writing it right now. What was the most useful or interesting thing that you learned or heard tonight from our really fantastic speakers? We really want to know. Who's got something? These 30 seconds always go by so fast, Jay. I think it needs to be a 60-second slide because everybody's already walking away.
They can keep typing after the 30-second timer.
I know, but then it seems like then I don't get to say it. And that's my favorite part of the whole night. Well, that's my second favorite part. The rest of the whole night is my favorite part. Well, we want to continue hearing you. I know that many of you are probably getting ready for your happy hour that's about to start before our additional Q&A. Thank you, Karen. So the different types of AI attacks that Chris shared. Fantastic.
That was my favorite too, Karen.
That was really good. And yes, I'm seeing people connect and share emails. We'd love to see that. So please continue. Thank you. We're so glad you're here. Please continue writing what you learned tonight in there. And then I do believe in less than 3 minutes, we're going to come back for live Q&A. Oh, model baby using non-robust data. That's great, honey. Thank you. So yes, so already go get a drink. Jay's like trying to step away from the computer as I was talking. Rush. This break really is for Jay to go and come back, and for everybody else to go and come back. Thank you. Thank you for everybody for being here. Please stay on because this is a time where you'll have an opportunity to get to dialogue with Chris and Sherri. We'll bring you on camera, get to be a panelist with us, get to have a conversation, get to make sure that your question gets answered. So, but we'll only be answering the questions of people who stay on board. So I'm looking at you. Who is it who is saying, ask Michael if you want to come. We'll be looking at you, Michael. We'll be looking at you. Satish, if you're still here. Daryl, if you're still here. I saw a lot of really great questions coming into the chat too. So please, Kate, I know you had great questions too, Miss Catherine Crego, Kate Crego. We want to hear your questions. So yes, yeah, stay here, Kate. Well, you had a great question. Since this is my time and I get to promote people, I'm going to promote you first, Kate. As soon as Jay gives me the thumbs up that he has his drink poured, and we can begin with our. Yeah, that's even better than a thumbs up. Okay, give me 1 second, Kate. I saw you had some Q&A, so give me 1 second to find you on here. And again, I love to have Kate come because she is with Austin Pathways. So let's bring Kate back on. There she is. I see her. She's still on mute. Kate.
Hey. Thank you so much. That was just phenomenal. Hi, Sherri.
Okay.
Hi, Chris. Thank you. That was great. I think about, the human mind, the brain, And thinking about Harvard's implicit bias research, that kind of the crux is neurons that fire together, wire together. And, but also thinking about Daniel Kahneman's work on thinking fast and thinking slow, the kind of the takeaway from those two bodies of work for me are that we can't always control or even predict what biases we have, but when we are aware of them and we're aware that they're problematic, we can interrupt them. And so it's important to balance that thinking fast and thinking slow. So I'm wondering, how can we, as individuals and as organizations and as a society, so I'm wondering, how does this concept or these concepts, how can they be analogized to AI/ML?
Well, I think this whole discussion of the data really is very important with your reflections, Kate, because I think that there's not an awareness that we need of data being the backbone of AI, right? And what kind of bias you can see in the data and how you have to kind of pull back the curtain.
Yeah, I think that's true, but we bump up against the issue that humans who are prone and vulnerable to bias are looking at data, looking for bias. So it's going to be hard. I think we have to take a scientific approach, which develops algorithms that prove the data represents the population, that prove that it has equal representation of multiple aspects of the population you're going after, and require vendors to share that proof to all the consumers, that this is how we validate it. This is what it looks like. This is the population of data we used. It's really metadata, data about data, but it's still sufficient to give people make an informed decision about the quality of what they're going to receive.
So caveat emptor, right? Buyer beware. Pull back the curtain and ask for that.
Right, exactly. You have a right to have that information.
Yes,
that's not proprietary by any means.
Exactly. And people don't realize that, Chris and Kate, they just don't.
Thank you.
Absolutely. Thank you, Kate. And thank you for all that you do with Austin Pathways as well. So who else? Throw it in the chat. I know that we saw Satish there. I don't know. Sometimes people.
How about Chris Van Hook? He's got a great question. He's actually got multiple great questions, but one of them about certain industries facing more AI regulation. I'd love to hear the presenters talk about that. Is Chris still available?
What's Chris's last name?
Chris Van Hook.
Okay, well, hold on. Give me 1 second. I'm going to switch some people around.
Oh, I don't see him on. Oh, no, you got him. Okay.
I already got him.
You got him.
There
Chris,
is.
you're on.
Chris, what's your question specifically?
Oh, he doesn't have a cam or.
Our industry is experiencing regulation for machine learning.
He's connecting from his phone. Oh, you can't even get off mute, Chris? Okay, well.
I have an answer for him if he wants to hear.
Go ahead.
There is a regulation in the Federal Reserve has created specific regulation for banks who do investments with machine learning models. And they require the banks to share the algorithm's approach, the model description, the scope, variability of the model. That they have very good, as a matter of fact, we've modeled much of what we've done in Cisco against the Federal Reserve's audit requirements for banks. And so I think that what they're trying to do is to get away from the issue of robo trading, which can cause a market to collapse. They want to have very sound, very, very legitimate models that do good analysis before they execute trades.
Absolutely. There's the circuit breakers that have had to be put in place because of the robo trading. And when I talked about, should we have some type of standards board, perhaps at the federal level, that includes industry and people from across the board, right? I'm getting at this very question. We've done that for, in fact, banking and some other industries that I was thinking of, but you have to bring together diverse minds from across all of the sectors, I think.
Yeah, I think healthcare will get it too.
Yes.
Healthcare is going to be getting regulation on machine learning. IBM, it's Watson was doing some good research on cancer
Mhm.
detection and treatment recommendations, but
Um,
it didn't garner lots of adoption because the model required a whole bunch of tests, because they wanted to use lots of data. So testing was extremely expensive whenever they tried to use Watson, and it didn't really gain a lot of support, especially
and
by
another,
insurance companies.
yeah, another thing to think about in the medical field is, for instance, take something like organ transplants, right? Are we going to have AI determining who gets off those lists? And if so, should there be regulations around it? That would be another example in healthcare.
Yeah, and I want to reinforce that we're talking about bias a lot. What I
Right.
want to reinforce is we're trying to avoid unintended bias, because we want bias to be able to detect right and wrong, which direction we take, but we don't want unintended bias that produces answers we don't expect. So
No, that's absolutely correct.
Yeah.
There are some situations where we need bias. We need to know who is most at risk, for instance. You could say that's a bias, but we need to know that who's most at risk. And it is those unintended, as you stated. But, you know, who is most at risk is a bias, but that may be, in fact, the very bias that we want to suss out.
And Chris asked, is there way more employing unsupervised learning models in the mainstream than elicit unintended bias? Unsupervised learning models help you to analyze the data that you have. They really don't detect and report a specific match or a feature, or what they do is they say, given this 5 petabytes of population data, we looked at it with 10-dimensional array, and we found these clusters of interesting things working together that sort of grouped together that were interesting. And you visualize that, and as a human you say, huh, I wonder what that means. So what that does is it helps you to look for patterns that you wouldn't normally be able to see. So it doesn't really cause bias. It uses the bias in the data to show you groupings and relationships you may never have seen before.
And it can do that with going through humongous amounts of data that the human mind could not in so rapidly.
Right.
Thank you. I just saw Diane sharing a question, so I'll let her share it. Give me 1 second to bring up Diane and switch some people around. There you are. We see you, Diane. If you want to come on camera, you don't have to, but if you can, come off microphone so you can chat with him. But I know you asked a very classic question about common sense being learned and some of the concerns. Diane, would you like to share your question? Are you there?
It appears to be on mute.
It does.
Mm-hmm.
Oh, well, I won't make people wait. So her question was, oh, Jay wants to pick the next question. That's fine. Can common sense be learned by MLAI? Do you have any concerns that MLAI will do harm to evolutionarily dehumanize the human? If she wants to explain, to tag on more, she can add more to the question.
Common sense.
I think we first have to define common sense.
Very true. That was like the one where it's like, I want to learn to read minds. I'm like, really though? Are you sure?
No, but it's a good question, because what we think of as common sense is intuitiveness or ability to apply learning. Diane, can you talk about that some more?
Can you hear me?
Yes,
Yes, we can hear you now.
Oh,
So,
okay, great. So I was thinking more about the out-of-the-box thinking. You were talking earlier that AI is really good with in-box thinking, but not so much creativity and out-of-the-box thinking.
Right.
yes.
And so over time, do you think we are going to lose some of these skills as a human? You know, how things change evolutionarily over time. And do you have any sense for how this might change us as humans over time? Will we lose some of that touch, some of that intuition, some of that humanistic qualities that we all seek and really crave in other humans, like we've all been craving human connectivity in this time of COVID isolation.
So I think what you're getting at is perhaps use it or lose it, right? If we're not using it, will we lose it? But I don't think that humans will quit using these this common sense and these innate abilities. First of all, I think they'll still be necessary, as I was saying. Yes, there may be some jobs that do not exist anymore, but there'll be new skills. And also there will be positions where humans are programming, managing, monitoring, working alongside AI, and for the very reasons that I think that you have just stated. And I think that humans will continue to use this and not lose it because of what you said. We crave it. At some point, we will be free to move about the cabin, right, beyond our cabins. And I think that there will be much more interaction, and for a while, even kind of interaction on steroids of the human nature.
And I think, Diane, your point is a very good one, because it comes up in law school today. Many law school students, I was one for a little bit, are now relying on machine learning tools to do legal analysis, to look for valid precedent, good law, and help with writing legal briefs. And law practices are using machine learning to do legal analysis for their attorneys, their litigators, and not the first-year law students, the graduate law students. And the concern is that these law students are going to grow up with no legal analysis skills. They're not going to be able to understand the law, how it applies or doesn't, and how to differentiate between good and bad law. So there is a significant concern right now among law schools and among graduates going from law schools to their practices, their first-year practices, that they're going to miss out on some really important skills. So your point is very well taken, Diane, that there may be atrophy in some professions because the machine learning will be faster, cheaper, and just as effective as a person would be. So that person now has to develop skills they may need to use later in life, later in the career, different ways than they had before.
And in fact, lawyers was something that I mentioned earlier you may not think about it, but the legal field has changed, will continue to change. There will be fewer lawyers because of exactly what you were saying, Chris, LexisNexis, all the different, there's always been search tools that lawyers use, but now it's at a whole different level. And I do think that's a concern.
And if I may just extrapolate a little bit further with your explanation, do you see that possibly in the future we'll be paying higher prices for in-person type services versus machine learning or AI services? And if we are paying higher prices, do you think some careers, like I can think of psychotherapy or counselors or social workers, would be actually flipped to where they're being paid more than a doctor or an attorney in some cases because they're giving in-person service?
Mm-hmm. Yeah, that's very possible. That's a very possible impact on work.
It is. And one of the areas that I mentioned as far as new jobs, right, was telemedicine and healthcare in general. So I do think that, for instance, we will continue to see greater use of telemedicine. It's something that's really been accelerated with the pandemic. And for a lot of people, it has provided healthcare that they couldn't have before. They didn't have transportation. They couldn't get away from their jobs. They didn't have childcare, right? And so, but you won't just have AI on the other side. You will have people who are very much trained in, I think, a whole new field really of medicine that is telemedicine.
Thank you so much for the conversation.
Thank you.
Questions, Diane?
Thank you, Diane.
Yes.
All right, how about we pick for our next question asker, Roy Truitt. Are you still on?
Hi, Roy. If you are,
You had a great question in there. You want to ask your question live? Jessica can promote you. Jessica has
I
the
found
power.
him. I already promoted him.
okay.
You're on. You don't get out of it, especially if your name is Roy.
Roy, you're on mute. Can you unmute, Roy?
I can't unmute people. They can only
No,
ask
I
them
mean,
to
Roy,
unmute.
can you unmute yourself? I should be more
Yes, Roy.
specific.
There
to
Hello, did that
the
work?
language.
Yes,
That
you're
worked.
here.
That worked.
Okay, now where'd my question go?
I don't know. Maybe AI can find it for you.
Jessica, read it. Just cut to the chase here. Thanks.
Need some more scotch.
Roy, I was specifically suggesting your question about government regulation and how do we expect our government to be able to make policies and decisions when things are changing so fast.
Yeah, well, that was my concern. Of, you're kind of in a governmental mind here for some reason. Not sure why the next few weeks, but it appears to me that the federal government in particular does not do a very good job of keeping up with technology. And you see this in the conferences where they have question and answer systems, questions they're asking people at Google, what are you going to do about the next television or something? You know, it's just, they just don't know. And so these are the guys who are supposed to make rules and regulations for things such as GPDR, GDRP, and you know, DNA, designer babies, ethical questions, and all this technology. And to exacerbate the problem was we're already way behind the curve. And as the technology accelerates, the government and regulators just get further and further and further behind. How are they going to possibly keep up with the pace technology is expanding to be able to apply regulations in a meaningful form at a time and place that might be meaningful to the direction in which this society moves?
Well, of course, I'm going to get back to education. And certainly there seems to be some lack of continuing education when certain public figures ask certain questions, right? So I will leave it at that. But I do think that we really have to focus on education at all levels and this multidisciplinary education and training and the continuing training. But to get to your specific question about what do we do today, that is why I said if we're going to have, you know, policies are one thing. When you make a policy, it's not like a statute. A regulation is statute, it's law, which is different from a policy. These are the kinds of things we'd like to do and follow versus a regulation that then becomes a law or statute, whether it's at the federal level or state or local. And that is why I think that we need probably at all levels of government, at the federal government, at the state government, and even within our cities, to have these standards boards, to have advisory committees that bring together people in government, in industry, in academia, and these need to be ongoing.
Now, I agree with that. The question is, how do you do that? Because you need interface between those who are developing the technology
Right.
with those that are not developing the technology, and in some cases don't even have that much interest in them. So how do you get those people together? Traditionally, the advances in technology has been left up to universities to figure out how it should be applied and pass that information down to the legislators. But the problem is the pace at which we are developing new technology in biomedical fields and AI and machine learning and just on and on and on and on. How the average citizen can't keep up. How do we bridge that gap between not necessarily the average citizen, but the people in the government that are regulating or should be regulating these kinds of things well in advance of when the impact will be felt for the general population?
Well, right. And that's why I'm saying I think the onus is on all of us to push for this and to have these standing, whether they're advisory committees or standard boards, set them up now, have people involved who are from government, from academia, from industry on an ongoing basis. This isn't a one and done. They're standing committees.
Yeah, I want to chip in on this one a little bit too. Sherri, I couldn't agree with you more. And Roy's bringing up the point of technology and the rapid pace of change in it. We've talked about this in the Austin Forum before, but we're seeing, and Austin Forum on Technology and Society is not a political organization.
No.
It is an objective 501c3. So it's not a policy issue. There are science issues and there are technology issues that I agree with Sherri. You need to have standing science advisors and
Right.
standing technology advisors. The science advisors, because the science is hard. The easy science was done a few centuries ago. The science now is hard. And it's going to get harder because we learn more about science, and now the questions get harder and harder. And that's great. It's actually great that our body of knowledge is increasing, but it means the amount of learning you need to have to answer the hard science questions is even greater.
Right.
So we must have scientists involved, but when making policy, and I'm going to say one slightly, we must actually listen to them. If you were having a brain operation, you wouldn't do that by popular opinion. You would go to the best neurosurgeon you could possibly find, who, by the way, lives down the hall from me here in the building. But
remember when Jethro couldn't decide whether we wanted to be, what was it, a fry cook or a brain surgeon?
Yeah,
we want the person who's trained as a brain surgeon.
We all need to accept the fact that since specialization and of labor and specialization of expertise, we need to be able to depend on expertise and trust that expertise in areas we don't have. And I think that I love Sherri's idea. We really need to have these standing committees and people on complex topics and on fast changing topics, and technology falls into the latter camp. It's fast changing. You may understand the technology today, but technology is advancing exponentially, but time for people passes linearly. So a few days later, or a few years later, that technology's moved far beyond where it was. And if you're not involved in that daily, you're not going to have the fundamental understanding. So you better be around people that do and can translate it. The wonderful news is we don't all have to learn everything from scratch. Books, the printing press, et cetera, enable us to learn from the people before us. But the rates of change for technology and the complexity of the new levels in science are such that we really have to do a better job of identifying and trusting objective scientists and technologists in these areas.
I agree with you and Sherri entirely, completely. The question I have is, how do we make that happen? How do we get that group together, those groups together? How do we implement that, now instead of, 10 years
So
from now?
there are, let me just say, there are people working on that. Okay, there are. And those people may be involved with different efforts, or they may be in academia, or they may be working, as I am, with a group that is preparing white papers for day one of whatever our next day is at the federal level.
That's terrific news. Thank
I
you.
was Roy too. I don't do it often, but I was asked to participate in a security technology advisory committee, along with Northrop Grumman and AT&T, and who else was there? Quite a few other large companies. And they were saying, what's the next thing we should be worrying about? What should we be focused on? How should we look forward and invest in research and invest in government activities to watch what's going on? And that was a great example of we have government officials who are inviting these people to participate and share their ideas and teach them what's going on.
And I'm actually involved in an effort right now to do just that on AI and standards with public interest technology.
For those of you who don't know Sherri's full background, she's worked in government as an elected official, in the higher ed space where she is now, and in industry on Wall Street. So she's really got a comprehensive set of expertise to think about the policy issues involved here.
I've crossed the sectors.
Is that because the grass is always greener in the other sector, or is that something?
No, I think it's just general curiosity.
Good. All right.
I was that kid who was always asking the questions.
Good.
In fact,
we like those kids here at the Austin Forum.
Yes. In fact, I actually, in second grade, and this is not how education should work. I remember in second grade, we were in math class, and they were telling us to do something in math, and I kept asking why. I understand that's what you're telling us to do, but what's behind that and why? So my reward from that was that I had to stay in at recess, and they brought the principal down to try and explain it to me. That's not how an education system should work, just saying.
Well, Jessica, do you want to pick the final question of the night?
So if you haven't gotten your question answered. I thought that that was going to be the final question since it was 8, Jay. So I was, yeah, I wasn't looking. So, but I would just have to do another call for questions. So who has not had their question asked? Because I want to make sure if we, for the final question, if we ask another one, that they're online too. It might be a good wrap up on that, Jay, is Sherri's nodding too, unless you have a question, Jay.
No, I see one that I'd like to end.
Oh, good.
Well,
Okay.
Jay, how about you have the final question, Jay?
All right, fine.
Go for it, Jay.
I really, by the way, this is the best set of questions we've seen since we've started doing extended networking. There are awesome questions here from Chris, Sam, Amy, Kate, Daryl, Bill, and Karen, and others. But I'm going to end on an interesting humanist note and ask Sam's question. I am actually, Sam is still here. Sam's going to ask Sam's question.
Yeah, Sam, please.
Sam, in your promotion of, it's the lowercase SAM.
Okay, I was going to say which Sam. Let me see.
And he asked a great question on the humanist side of things. Sam, are you here? You got to unmute, Sam.
You have to unmute yourself, Sam. There you go.
No, here I am. I was wondering if you guys could say, are there any specific jobs where people are doing philosophy with related to AI with philosophy of mind? Or you talked a little bit about people doing ethics. Is there a place to look? Also, maybe you can say a little bit about some of the issues in that realm, if you know.
So there's actually a whole field of research behind this. And one of my colleagues at the School of Information at UT really specializes in philosophy and AI. So it is a whole field of study, and there is a lot of philosophy behind it, because when we talk about ethics, we really need to start, I think, with philosophy and the earlier philosophers and move forward from there. So it's actually a whole field of study.
So maybe look at your program and try to see more what people are studying in there.
Yes, yes, yes. And if you reach out to me, I could connect you with some people, but there is this is a whole field of study now.
And Sam, I will tell you from my day job perspective at Dell Technologies, we're starting to care deeply about, Dell's noted as a very ethical company in terms of recycling and things like that. So we're starting an internal initiative on AI ethics, because as Chris said earlier in his presentation, you're getting some probabilistic answers with potentials for various kinds of attacks, various kinds of bias, et cetera. And yet AI offers this very cheap, efficient, fast capability for making decisions after training it on lots of data. So if you're going to allow AIs to make decisions, you have to make sure, and the decisions impact people, you've got to make sure they're ethical decisions. So I think, Sam, you're going to hear a lot more in the coming few years about ethical AI. And
you absolutely are. And that is the whole effort, again, behind good systems at UT, is ethical AI. Absolutely.
Some qualify it as responsible AI. That's how they describe it as well. But we're getting questions from customers asking us, well, I've seen Google say what they do with AI. What is Cisco doing with it? What are you doing in responsible AI and ethics in AI? So we're responding quickly to say, we don't know. Let's figure out what we're going to be doing about that space. Let's make some serious effort to define what we do and what that means to Cisco. So just like Dell, we're doing the exact same thing because customers are expecting it from us.
And it's similar to what we saw years ago. You know, in a market economy, you can get some quick responses, particularly when your customers and even your employees are asking. And we saw this years ago with social investing, right? Back to one of my former backgrounds, which was Wall Street, but with social investing, where the investors started demanding, you know, I want part of my portfolio to be something that I invest in that I think provides a social good, for instance.
Mm-hmm.
Yeah, I think this topic really, this whole topic of AI ethics really ties the technology and society dimensions of the Austin Forum together really well. We are on the cusp of releasing so many decisions we make to automated systems. In fact, The CTO of Dell Technologies likes to say, we're accumulating data at a faster rate than humans can ever process it. We are going to have to release the decision-making in complex systems to those systems.
Right.
So it's going to be crucial that these systems make ethical, responsible decisions, and humans are going to have to teach it how to do that. It's not going to teach itself. These are machine learning algorithms, not machine fundamental principle algorithms. So it's going to be up to us to do that. So Jessica, I think that is the final question for the night, right? You're on mute.